Hi there, welcome to the Retro Desk. I'm Matt Heffernan. This is the first lesson of my new tutorial series for people to learn programming using the Python language. This tutorial is for absolute beginners, no experience necessary. We're going to start with the most basic concepts, and over the course of this series, learn how to make your own game. Today's lesson is going to be all about getting familiar with how programming works in general. I'm sure you've heard the word code as a verb, as in, if you want a good job, learn how to code, or kids should be coding in school. You may have an idea of what that means, but today you will learn what code actually is and what it really means to code. Code, as a noun, refers to instructions that are given to a computer to perform a certain task. That can be as simple as adding two numbers together, and as complex as running a giant website like YouTube. The main thing to remember is that computers don't know what to do on their own. The programmer has to tell it exactly what to do, and the computer will follow those instructions perfectly and as quickly as it can. A computer only does the wrong thing when the programmer fails to tell it how to do the right thing in the right way. Python is just one of many languages that have been created to make writing code easier for people. The native machine language of computers takes a lot more technical knowledge to use, and generally makes programming much more difficult and time-consuming. Python is what is called an interpreted high-level language, in that it takes another program to read and run the code you write, and it's geared more towards human understanding rather than how the computer works on its own terms. This makes it easy to learn and use for beginning programmers, and the first program we are going to write has only one line of code. Print, open paren, quote, hello, comma, Python, exclamation point, quote, close paren. Python, like most programming languages, uses plain text for its code. So what does plain text mean? You are certainly familiar with the concept of text, as in text messaging. Plain text is just what it sounds like. Text without anything else, just regular characters. There's no different fonts or sizes, or any non-text content like graphics or animation. A word processor like Microsoft Word or Google Docs lets you write what's called rich text, which can have all this extra stuff. A text editor, like Microsoft Notepad or Apple TextEdit, only lets you create plain text, and that is what you will need to write Python code. However, we aren't going to use just a simple text editor. Instead, we will use what's called an Integrated Development Environment, or IDE for short. You can use pretty much any IDE to write and run Python code, but for this series we are going to use Thonny, which is a free and open source IDE specifically made for beginner Python programmers, like you. If you don't have Thonny already installed, you can easily get it by going to thonny.org and download the version you need. Thonny is available for free for Windows, Linux, and Mac, and even comes pre-installed with the Raspberry Pi OS. When you run Thonny for the first time, you will see a window with two panes. On top is a text editor where you can write your code. On the bottom is a shell where you can run your code. So let's type in that first line of code. Print, open paren, quote, hello, Python, exclamation point, and close the quote and close the paren. Now before we run this code, we need to save it. So we click the Save button, and we'll call it Hello, and click OK. Now we can see that the tab above the editor says hello.py. Thonny went ahead and added the .py extension to our code file so that it is identified as Python code by Thonny and other applications. With the code saved on our computer, we can click the Run button to run it. And down below in the shell, we can see the output of our program, where it printed Hello Python, and then we got a new prompt of 3 angle brackets. Now let's unpack what all this means. So we just created our first plain text file containing Python code. Let's take a look at that code again. We wrote print, open paren, quote, hello, comma, Python, exclamation point, close quote, and close parentheses. First, what does print mean here? Well, as we saw, nothing came out of a printer, but we saw the text "Hello Python" appear in the shell. That's what we mean by printing, having text appear to the user from a command prompt. So what's a command prompt? Well, those 3 angle brackets in the Python shell is an example of a command prompt, where we can type in commands and make things happen, like running programs, and see text get printed back to us in response. You may have used the command prompt on your computer before, which uses another shell for your operating system, like DOS shell or PowerShell on Windows, or Bash shell on Linux or Mac OS. Here's what the Bash shell looks like on Linux, where we get a $sign for a command prompt, usually with some other information before it. If you have Python installed on your computer, you can type Python at your command prompt and hit the Enter key, and this will take you to the Python shell and that same 3 angle bracket command prompt we saw in the shell in Thonny. To keep things simple in this tutorial, we're going to stick to using the shell in Thonny until we get much further along. So when we want to print in a shell, we use the print function and give it a string to print. But what does that mean? For our first program, we used our first function, namely print, which is a function that is built into Python. Just like in math, a Python function can take an input and produce some kind of output. For print, our desired output is text getting printed to the shell, and the input will be the text we want printed. Again, just like in math, a Python function has a name, and then the input arguments go into a pair of parentheses to the right of the function name. So our code is calling the print function and passing in a string of characters that read "Hello Python," and that's it. The quotation marks tell Python that the argument is a string, which is what we call a bit of text in code. It is a string of characters, capital H, little e, little l, and so on through the exclamation point at the end, that we want to provide to the print function as input. So we close the string with another quotation mark to indicate the end of the string, and then a closing parenthesis indicates that the string is the first, last, and only argument to the function, and that the function can then be run. Here, this one function call is the only thing our code does, but under the hood, Python is doing a lot of stuff to run that print function and make that text appear in the shell. Luckily, we can just use the print function to do that, so we don't have to be bothered with all those technical details. Okay, we just went through a lot, so let's review the terms we've learned so far. Code is what we call the content of our program, which is a plain text file that we can write in a text editor. It's also a verb for the process of writing code. Such a versatile word. A text editor is an application for writing plain text, which is a necessary tool for coding in Python and most other programming languages. An integrated development environment, or IDE, is an application that combines a text editor with other functionality to make writing and running programs easier, like Thonny, our IDE for Python. A shell is an application where we can type commands into a command prompt and get text printed back to us. The Python shell is integrated into Thonny to make it faster and easier to run our programs. A function is a bit of code that's already been written that you can call in your code to perform some kind of task. It can take arguments as input and have some kind of output. Arguments are the things inside the parentheses of a function call. They are the input to the function named to the left of those parentheses. A string is a bit of text, a sequence of characters that you can have in your code inside a pair of quotation marks. In our code, we pass the string "Hello Python" as an input argument to the print function, which then proceeded to print the text in that string to the shell. How are you doing, okay? If that review left you a little lost, go back and watch the beginning of the video again. This tutorial is all about learning at your own pace, so if it takes you a few attempts to learn something, that's okay. If you are feeling comfortable, we're going to move on to another important part of coding, variables. If you took algebra, you should already know what a variable is. If I say x equals 2, then I have defined a variable named x and given it the value 2. If I then say y equals x plus 3, then I have defined another variable named y and assigned it the value of whatever x is plus 3. So if x is 2, then we can plug that into the expression x plus 3 and get 2 plus 3, which of course is 5. So we are effectively giving y the value of 5. In Python, we can define variables just like this, as if we were in algebra class. Are you starting to regret not paying attention? No worries. It's really quite simple, and it's actually easier to learn and understand algebra concepts when you are coding than just doing math homework. Python lets you set variables to numbers, but a variable can also hold a string. Ask your math teacher if they can do that. A variable in Python can also be more than a single letter. It can be a word, like message, which we can assign the value hello Python in quotes. Then instead of typing out that string in our code, we can use the message variable to refer to that string and pass it into the print function like this, print parens message. Let's go back to Thonny and change our program to do this. Let's insert a line at the top of our file and to type in message equals space, and then we can cut and paste our string to the end of this new line. Go, cut, and paste. Now we can go back to the call to print and put the variable name message between the parentheses. Now you can see we don't use quotes around the word message here like we did before with hello Python. That's because we don't want our program to literally print out the word message, but the string that is assigned to the variable named message, which as we can see in the line above is hello Python. The fact that this line comes first is important. Our code will get run one line at a time, starting from the top, so we want that string assigned to the message variable before we pass it to the print function. If we had those lines reversed, the code will not work as intended. First, let's try running it. If we click the Run button, we see that same string get printed to the shell. So now our program is doing the same thing as before, just taking 2 lines to do it instead of 1. You may also notice that the Save button grayed out when we click the Run button. Since we already saved our code under the file name hello.py, Thonny went ahead and saved our changes for us automatically. Wasn't that nice? Now let's try doing something not so nice to our program, like reverse the order of the lines. We can do that with another cut and paste job. Okay, now let's try running again. Uh-oh, that doesn't look good. We just made our first coding error, which was intentional, but still not what the shell wanted to see. Notice that it failed to print our message this time, and instead we get some scary red text telling us there was an error, and message was not defined. That's because we tried to call the print function using the message as an input before we assigned it a value. In Python, if you don't assign a variable a value, it doesn't exist yet. So when we use a variable name in our code, we need to make sure that an earlier line assigns that variable with the value we want. If we go back and undo our changes and get those lines in the right order, our program works again. We just fixed our first coding bug. Now, if you remember, the first example I showed you of a variable was for a number, not a string. It probably surprises no one to learn that variables in Python can be assigned numbers as well as strings. So now let's edit our code one more time to replace our old string with a number. Let's say 42. If we run it, we see that the print function still works, even though we passed it a number and not a string. If it was a string, we could have put quotes around 42 to make the message the characters 4 then 2. But without the quotes, we have a number and not a string. And yet the print function can still make it a string that it prints out. Since message is now a number, we can do some math with it. Let's add 58 to get an even 100. To do that, we're going to just type in space plus space 58 to the end of the assignment line and then run it again. Well, look at that. Python can math. Let's make it a little mathier now. We can insert another line at the top that assigns 42 to a variable named x. And replace that 42 in the next line with x. We run it again, and we get the same result. Now we have defined 2 variables, one named x and then one named message, that we assign the value of x plus 58. Now, the message variable is still a number, but that doesn't make sense. A number is just a value. It's not saying anything. So let's rename message y, so that now y equals x plus 58. We are still passing the message variable to print, so this code won't work if we try to run it now. There's that pesky error again. We still need to define what message is, so let's assign it a string again. This time, the value of y is, and that's it for now. We can run this, and we are now printing a new message, but doing a bunch of math before that for no apparent reason. Python is still doing the math, but we have no evidence of it in the shell output. So let's make our message make more sense and add the value of y at the end. Let's try doing literally just that and type in plus y after our string and see what happens. Uh-oh, another bug. It says something very weird. Type error can only concatenate str, not int to str. What does that mean? Let's go back to the drawing board. In our program, we are dealing with two different types, numbers and strings. These are what are called primitive types in Python, meaning they are a basic part of the language. And really, our numbers aren't just numbers. They are specifically integers, meaning they don't have any decimal points in them. They are just simple whole numbers. In Python, integers have the type int, which is short for, you got it, integer. Python automatically made both x and y variables of this type int because we assigned integer values to them. First, we assigned the integer 42 to x. Then for y, we assign it the value of the expression x plus 58. Since x is already an integer and 58 is an integer, we are doing integer math, and the value of y will also be an integer. We made the message variable a string again, assigning it a value in quotation marks, but then try to change it by assigning it an expression where we try to add an integer to a string. Python doesn't know how to do this. It can only add integers to other numbers or strings to other strings. Adding a string to a string is called concatenation, which literally means adding a string to the end of another string to make one longer string. Let's go back and make a first attempt at fixing this code. So we can't just add an integer to a string. We need to add another string to do a proper concatenation. Let's make y a string by adding quotes around it. When we run it, we see the program works, but not how we intended. We just added the literal string y to the string the value of y is. So we do have a true statement. The value of y is indeed y, but that doesn't tell us anything of actual value. We want to print the value of the variable y in that place so that we can see the number 100 get printed again. To do this, we need to convert the value of y to a string. To do that, we are going to use another built-in Python function called str, which is short for convert to string. We are going to pass the variable y as an input to this function, and then the output of that function will be a string that we can add to our other string. And now it works again. Okay, that's a whole lot to get our heads around. Let's go back and talk about what this means. The first function we used was print, which performs a process to print text to the shell. What it did not have was a return value. In math, all functions have arguments and resulting values. But in Python, a function doesn't need to have either. The most basic kind of function has no arguments and no return value. It just does a thing without any input. Python has a built-in function like this called exit. If you call exit in your program, it will just exit immediately, even if there are other lines after it. In fact, if you are running your code in the Python shell, it will exit the Python shell itself. We'll see how that works another time. The next kind of function just takes input arguments and has no return value, like print. The only output we care about for the print function is what we see in the shell. The str function has both input arguments and a return value. That means when we call the function, it results in a value that we can use in our program. For instance, we assign that value to a variable like this: y_value_string equals string parens y. This will define a new variable named y_value_string, and it will contain just what it says it does, the value of y converted to a string. The str function takes something that isn't a string, like an integer, and converts it to a string, and returns that string so that it can be used for another purpose, like printing to the shell. This is a lot more like how a mathematical function works, like sine, except instead of converting a number to another number, we can convert a value of one type into the value of another type, like an integer into a string. A good way to see how this works is by using the Python shell. In the shell, instead of running a whole program, we can try running just one line of code at a time. So let's do that with the first line, x equals 42, and hit enter. Now we get another prompt, and that's it. Nothing got printed to the shell because all we did was define a variable, namely x. Now if we want to see the value of x, we can simply type the name of the variable in the shell and hit enter. As you can see, the shell just prints out the value 42. Now let's do the second line, y equals x plus 58, and hit enter. Now we have defined two variables, with the second one based on the value of the first. If we check the value of y, it's 100, just as we expected. Now, instead of typing in the whole next line, let's try just calling the str function, str parens y close paren. Now, we didn't assign the return value to anything, so the shell just runs the function and prints the return value, which is the string 100. Let's do the assignment we saw on the last slide. y_value_string equals str y, which will define a new variable and assign it the return value of the string function. The string function converted the number value 100 into a string, and by assigning it to a variable, we now have a variable containing a string version of the number 100. So if you just type the name of the y_value_string variable, the shell will print out its value, which is the string 100 and not the number 100. This is an important difference. The string is a sequence of 3 characters, a 1 character followed by 2 0 characters, and not really a number. It's just a way to write a number using text. Now, since we already converted the number 100 into the string 100 and assigned it to the y_value_string variable, we can rewrite the third line of our program to use this new variable. Message equals the value of y is space plus y_value_string. Now if we type the name of the message variable into the shell, we get its value. The string, the value of y is 100. You know this is a string value because it has quotes around it. Now if we do the fourth and final line of our program in the shell, print message, the contents of the string message are now printed to the shell without quotation marks. This is for 2 reasons. First, the print function prints strings to the shell, so the quotes are just how we identified literal strings in our code, but those quotes aren't part of that string. Second, the print function doesn't have a return value, so when we call it from the shell, it just does its thing, which is printing a string, and then we don't get any sort of value coming out of it, like we see with the string function. You should also notice that the Thonny shell prints this text in black instead of blue. That's how you know when something is getting printed to the shell by the function you just called, or it returned a value, which would be in blue. Okay, let's go back and review. So functions can be just a simple command like exit with no arguments or return value. They can have arguments like print that do something but doesn't return a value. They can have both arguments and return values like str that does something with an argument, in this case takes a number as an input and converts it to a string, which it returns. That return value can be used in an expression like adding it to another string to concatenate them into a longer string. Or you can just assign that return value to a variable and use it later, as we did in the shell. There are also functions that don't take arguments for input but still have a return value, like locals, which will give you a list of all the local variables you currently have defined. Even though it doesn't have arguments, we still need the parentheses to tell Python that we are calling a function. Let's go back to Thonny and try that in the shell. Okay, let's see our local variables. We'll type in locals, parens, and hit enter. Well, that's a lot of stuff, but it isn't red, so we know we didn't do anything bad. It's blue, so we know that we are looking at the return value of the locals function. There's a lot going on there because this is something more complicated than just a string or a number, and that it contains a bunch of both of those along with some braces and colons and stuff. We'll get into what that is in another lesson. But for now, you can pick out all the variable names we defined and their values, like x is 42, and the contents of the message string. Pretty neat, right? Okay, now that we've seen all the different kinds of functions and how they can be called, let's write our own function. So far, we've only been using built-in functions, and that's good enough for simple things like we've been doing. But most programs are going to define functions of their own to do things that need to be repeated. This helps to keep code from getting longer than it needs to be and makes it easier to work with, so that you don't have the same sequence of lines over and over again in your code. To define our own function, we use the def keyword, which is short for define, and then a space and a name of our function, which we'll call print value. Then to define our argument, we follow the name with parentheses. If our function doesn't need arguments, then we would leave the parentheses empty, just like when we call it. But in this case, we want an argument that we'll call value, so we'll just put that right inside the parentheses. Then after the closing parenthesis, we have a colon, which means that the code for this function begins on the next line. The lines for a function in Python need to be indented to show that they are part of the function and not part of the rest of the code. Our function will just have one line, and we're going to borrow from the code we already wrote. We're going to have this function call the print function to print the value is space followed by the value that was passed in as an argument. Since we can't assume that the value is already a string, we will force it to be one by calling the str function, which should convert whatever value is to the equivalent string. We need to close the parentheses for the str function and the print function, so we end this line with two closing parentheses. Calling the functions within the arguments of other functions is something that's done a lot in Python, so we need to be careful with parentheses. This function doesn't need to return anything, just print the string it puts together, so that's all we need to do for it. Let's go back to Python and start fresh with this new function. We're going to go ahead and delete all this code in the text editor and type in the definition of our new function. We start with the def keyword, and then a space, and our function name print value. Then our open paren, the name of our argument, which we will call value, and then close the paren and a colon. When we hit enter now, the Thonny text editor helpfully indents the next line for us, as it can see that we are writing a function, so the next line needs to be indented. We type out our one and only line, print, open paren, the value is, end quote, plus str, open paren, value, close that paren and the other parens, and hit enter again. Now Thonny's expecting us to type the second line of our function, but that's all we need for this end, so we'll hit backspace and get rid of the indent. If we run the program now, it's pretty anticlimactic. All this code does is define the function. it never actually calls the function. So let's add some more code to do that. Let's hit enter again under that function to give ourselves some space, and then call the function by typing print value 100. Since the function is defined now, we can call it just like one of the built-in functions, and we're going to pass in the number 100. When we run it, we see that it prints the value is 100, with 100 spelled out as 100. So it converted the number 100 to the string 100 and added that to the end of the string the value is, and passed that to the print function, which printed it to the console. Now, if we want to print another value the same way, we don't have to write that function again. We just call it again. So we can add print value 42 to the code, and now we get 2 lines printed when we run our program. Just like with the print function, our function can take an expression as an argument. So let's do a little subtraction this time. We'll put in a -25 and try it now. This time we can see we are printing the value 17 for the second line. This time we perform a subtraction and convert a result to the string 17. Now let's call this function one more time, but with a string for an argument. Let's do print value hello, which should pass the string hello to the function. When we try to convert a string using the str function, it effectively does nothing. It just returns the original string, so we see that here. We just get that string tacked on as the value is hello, and with that, I think we're ready to wrap up this first lesson. So today, we learned how to code. Congratulations! Of course, we have a lot more to learn, but today we got down to the basics of what it means to code in Python. We installed the Thonny IDE and learned how to use both the text editor and the shell and saw how they could work together. We wrote a couple programs using built-in functions like print and str, and wrote our own function that makes use of both of those. We learned about how functions can have arguments and return values, but don't need to have both or even either of them. We started plugging bits of code into the shell and learned about variables and their values, and some of the types of values that can be assigned to those variables. It should be enough to encourage you to try more things with Python and see how they work in Thonny. The more you program, the better you'll be at writing and understanding code. In our next lesson, we will expand on these topics and get closer to learning how to write any kind of program, even a game. I want to thank you for watching the first lesson in the series, and I can't wait for you to see the next lesson. If you aren't already subscribed to my channel, make sure you do that now and click the bell to be notified when the next video comes out. If you want to support my channel more directly, you could become a member here on YouTube or join our Patreon community, like the people you see here. Members and patrons get to see all my videos before they are released ad-free, along with other nice perks. Thanks for watching, and I'll see you again soon. Bye-bye.